7.7, you're now going to take what you know about radians, instead of drawing them where they are, knowing what quadrants that they're in, you're now going to have to do some trig functions. When I look at the kind of problems that you have to do, in the problems that you have to do, now you're doing the sine of pi over 2, or the cosine of pi over 3, or the tangent of negative 5 pi over 6, or the cosecant of 5 pi over 4, or the point on the unit circle that has an angle of 3 pi over 2. You're going to have to now add all 6 trig functions with the angles being in radians. And so what I wanted to remind you of was that you are still going to use the same techniques that you learned in the 3rd worksheet and the 4th worksheet and the 5th worksheet. You can either draw the triangles with a radius of 1 where the sides will be fractions, or use the one with the radius of 2 because your reference angles will still reduce and it still works out. Or you can memorize the unit circle and use its ratios, or you can use Mr. Promo's hand trick. Do you remember the quiz today? Were you allowed a calculator? No. Were you allowed to use the unit circle? No, you had to do everything from memory. That's the same thing that goes with these radian angles. So make sure you are getting down what's where, how is it placed on the unit circle, or what have you. So the one thing I didn't really mention the last time we were talking about the hand trick, if you are a person who uses this, the only thing that I have here that we didn't write down were the radian measures. 0 radians, pi over 6, pi over 4, pi over 3, pi over 2. What I like about them is, if it's pi over 6, I know that the 5 pi over 6, the 7 pi over 6, the 11 pi over 6 all use this reference angle. The pi over 4, the 3 pi over 4, the 5 pi over 4, the 7 pi over 4 all use this reference angle. The pi over 3, the 2 pi over 3, the 4 pi over 3, and the 5 pi over 3 use this reference angle, and so on. So keep that in mind. I still use this all the time. Everything else that we do are just examples. And I'm curious, because I don't know, this is my first time teaching it with your class. How many of you draw triangles with a radius of 1 or a radius of 2 when you do them? That's your preference. That's what I like to do. Raise your hand. Okay, I'm seeing one hand. How many of you have memorized the unit circle and use its ratios? Please raise your hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Maybe 11. How many of you use Mr. Promo's hand trick? Raise your hand. 2, 4, 6, 8, 10, 12. Okay, so maybe about 16 to 17 of you. There you go. I will be showing primarily number 3. Sometimes I will use number 2 then, and the one student who does number 1, you can still use it. It works. But I now know to show parts 2 and parts 3. Here we go. Number 4. Feel free to do these in your packet if you like. What I do is I just simply think of this. Oh, whoa, how did that happen? My unit circle. Pi over 2, I know exactly where that is. That's half of pi radians. It's straight up. And I know on the unit circle, I know that that ordered pair is 0, 1. Sine is the y value. The way I remember that is I think of sire and I think of coaxer. I know that's a really weird thing to say because I don't think we wrote it down anywhere. But we did write this down a while ago. And we did write this down a while ago. And when I say sire, coaxer, that's how I memorized those two formulas years ago when I taught advanced mathematics. So I remember the sine deals with the y and the cosine deals with the x. Sire, coaxer. It was a way for me to remember it. If it helps you, use it. Sine deals with the y. What's my y coordinate of this pi over 2? What's my final answer here? It is 1. It's your answer. How long does it take you? 5 seconds? 10 seconds maybe, max? That's why our quiz, the quick quiz, is called the quick quiz because of that reason. Number 5, pi over 3. The hardest part about students knowing pi over 3, I always go back to my hand and I say 0 radians, pi over 6 radians, pi over 4 radians, pi over 3 radians is this hand. How many fingers, square root of fingers over 2 is? And that's your answer. That's it. There's no more work than that, really. I draw where it is so that I can get partial credit in case I'm in the wrong quadrant. I mean, and if you're in the wrong quadrant, it depends whether this is negative or positive. Number 21, negative 5 pi over 6. I usually just draw where is negative 5 pi over 6. Instead of going positive, we go negatively, right about there. Because if I was at negative 6 pi over 6, I'd be right on the axis. So I have to be just short. How much short? Pi over 6. So if I know where pi over 6 is on my hand, I fold that finger down, pi over 6, and I do the sine divided by the cosine. Is the tangent positive or negative in quadrant 3? It's positive. And I have 1 over root 3, but that's not rationalized. So then I rationalize it by multiplying by root 3 over root 3, and I get root 3 over 3. I'm sorry, multiplying by root 3 over root 3. I think I didn't say that correctly. 5 pi over 4. 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Because some of you use the triangles, let's say that I go here, this side is negative and this side is negative. If I did the radius of 2, it would look like this. Or if you're using the hand trick, you fold down the pi over 4. The cosecant is cousin to the sine. The sine is root 2 over 2, but you need to do the reciprocal of it. Instead of O over H, it's H over O. Is that rationalized? Shall we rationalize it? Let me rationalize and show you this one just in case you have forgotten. This would make 2 on bottom, 2 root 2 here, and that would reduce. So my final answer would be negative root 2 for the cosecant of 5 pi over 4. If you feel like you are understanding what's going on and you're following what I'm doing, please raise your hand so I can see how many understand what's going on. Okay, there's some of you a little iffy. Okay, I like it. 70% of you look like you understand what's going on. I'm going to keep going. If you need help or individual help, I will be able to do that here after this last problem. Give the point on the unit circle that corresponds to the given angle. They're asking for the x and the y coordinates at 3 pi over 2. I hope you know where that is. If this is pi and this is half of pi, you can think of it like this. This is 1 pi over 2. This is 2 pi over 2. And then 3 pi over 2 would be straight down. That's our angle. What's the coordinates? The point. The ordered pair going straight down on the unit circle. 0, negative 1. Give the point on the issue that corresponds. There is my answer. That's it. That's all they're asking for. What are your x and y coordinates? That brings us to the end of our notes for today.